Welcome back, AP Statistics, the voice of none other than Mr. Riker. Mock exam number 7. Man, are they ever going to end? I was going to say I hope not, but I think I'm almost done. So I hope these mock exams have been helpful for you and that you've been timing yourself, having your cheat sheet. Hopefully you haven't had to rely on it too much. But FRQ number 1, we had parts A, B, C, D, E. A lot of writing on this one. This was based on a previous AP exam question from 2005 that I doctored up to make it a little more relevant to our exam that we're going to experience soon enough. We have a STEM chart, STEM plot of caloric intake for the random sample of 9th graders at one urban school and at one rural school. Now that's really important to read that carefully. This statement right here, a random sample of 9th grade students from one high school in a rural area and in an urban area. You'll be asked questions about that later. And this variable of interest is quantitative, and it's the caloric intake measured calories per kilogram of body weight for each student. Some students need more calories than other students based on different factors. So that's good that they have not just the total number of calories consumed, but calories per kilogram of body weight. And the first question is write a few sentences comparing the distribution between these two schools on this variable. I think that's a very realistic question that you'll see on the AP exam this year, comparing or describing. And note, when it says comparing, you should use comparative language, and you should use context or mention the variable of interest. So right here, I have the distribution of caloric intake of 9th graders. You should also mention these two things. You should be mentioning the rural and the urban settings, all using comparative language, as well as addressing SOCs. With quantitative data, like in dot plots, box plots, stem plots, you do SOCs. So we have, let's highlight some things. We have a higher, comparative word, higher center for caloric intake in the rural area than the rural school than the urban school. There's slightly higher variability for the rural school. I calculated just to, it's only slight. The range is 19. For rural, it's 51 minus 32. Range is 19. Compared to the range for the urban is 42 minus 26, which is 16. So just glancing at it, I might even say they're roughly the same. But if you actually calculate the range for the rural is bigger. Also, the standard deviation, since there's such a big group right here, the urban area probably has a smaller standard deviation, but maybe not. Maybe it doesn't because of the symmetry here. So it's kind of hard to tell. And please don't calculate. Don't type all this information in your calculator. That would be a waste of time. Remember, calculators shouldn't really be necessary on the exam, or very minimally. And then lastly, we have the urban school is right skewed, but the rural school is roughly symmetric. Again, you probably don't want to say roughly normal. It's not really like a really pretty kind of shape like that. I think if you said roughly normal, it might just be kind of like frowned upon, but maybe not docked points. But you don't really have many tails, right? It's more like a uniform. It looks more kind of like that than having these tails on the sides. So roughly symmetric would be a better description. And right skewed, you have a big group on the left, the lower values, and then the tail goes to the right. So you kind of have to like rotate and flip this urban diagram to see that it's right skewed. Right skewed meaning skewed towards higher values. And then I also mentioned outliers. I've provided the data more for myself if I ever want to remake this graph than for you, but there's the data there. So a question like this would probably score an E if you did shape center spread shape, center, spread. You use comparative language, comparative like great or, less or, and you use context. You'd probably get a partial if you did like 3 or 4 of those 5 things. If you only did 2 of those things, like if you mentioned the context and compared the centers, there's way more to say, so that might be an incomplete. Sometimes a partial could be like 2 or 3 or 4 to get a partial. All right, moving right along. I wondered what you thought of this question. I wanted to, again, talk about paired designs, and I wanted to give you a case where it would not be a good idea to do a paired design. So I even tried to convince you with this like really awesome looking box plot. And I wonder, did I convince you? Because if I convinced you for a paired design on B, then you might have gotten the hypotheses wrong on C, but we'll see. So I said, it's not appropriate. The pairing idea was, hey, let's take the kid with the lowest caloric intake from the urban school, and let's pair them with the kid with the lowest caloric intake from the other school. Well, the problem with that is whenever you do pairing, you want to pair by something that you think might influence the response rather than the response itself. The response itself was the caloric intake. So maybe if you would pair like, hey, I want to take these 2 athletes who have similar weight, and I'm going to pair them on urban is going to be paired, I'll just do a little plus, paired with a rural. And then, so that's one pairing. Maybe we have another athlete, they're both athletes, if I could spell athlete, and they're similar weight. And I'm going to take one urban of that, athletic build, and then I'm going to pair them with a rural student with some build. And then that would be an appropriate pairing. You do that before. The pairing should be done before you collect the data, not after. We have no reason to believe that the 2 lowest caloric intake students in the urban and rural have some common characteristic other than that they have low caloric, but that's the thing that we're measuring. So outside the response variable. A proper paired design would pair based on some characteristic that may affect the response variable, not the response variable itself. And that's kind of a nice summary of the idea of pairing. There was a question on the AP exam, not this one, but I kind of got this idea from another AP exam question. So it's definitely something that could be asked. Is the pairing appropriate? You could also say, I didn't include it here, but you could also say that we have 2 independent samples. We have the one from the urban and one from rural. So the data itself, it doesn't come from one sample where you have paired differences collected. So that would also be a good answer that like, no, the 2 samples are independent. The 2 schools are independent of each other. They're not linked. They're not dependent. They're not paired together. So that was B. And then to talk about scoring, since I made up this question, I don't have the like any scoring guide, but the scoring could be pretty strict in the sense of like mentioning the context, coming up with a reason why they're not paired, and maybe even, sometimes this happens, maybe even kind of like the pro and con, like what should it have been if it was paired? Now they didn't, I didn't specifically ask you to address that, but again, just a good test taking if you're asked to decide between like, or to explain which method is better, method 1 or method 2, or is this paired or is it not paired? It can really strengthen your response if you say, well, no, it's not paired because of this reason. If it were paired, it would look like this. And that would really convince the reader that you know what a paired design is. And that would ultimately be the point of this question. Do students understand matched pairs design? Question C. I've asked many questions about writing hypotheses and name the test. I think that you'll have a question like that. And notice this is a 2-sample t-test. They're 2 independent 2 independent samples, so we should use a 2-sample t-test for the difference in means. And I've included here, just in case I fooled you on B, you should not be saying a paired test. Now, if you said a paired test, typically on the AP exam, how that would be scored, if you did say, yes, it's paired, then on C, the hypotheses you would write would be mu of, say, like urban minus rural equals 0. And then mu urban minus rural does not equal 0. That's if it was paired. So if you did that, you said paired, and you said these 2 means that I have written in red there, then you would get an E. And that's how the AP exam scored. We don't want to dock you twice. You made a mistake in B, and that's fine, but you understand if it was paired, these would be the correct hypotheses. However, if you've said it's not paired, which you should have said it's not paired, these would be the hypotheses that you write. You have 2 means. This is a 2-sample t-test, so you should have 2 mu's, 2 means. And it doesn't matter if you did mu urban minus mu rural, you can flip-flop those. As long as you have 2 means, not using X bar, but mean, mu, the population mean. And make sure you define the parameter. Make sure you do that part. Defining the parameter, mu is the unknown population mean caloric intake for adolescents in each school. Might be better than region, but each school, rural or urban. Letter D was a question, and letter D and E were both actual questions from the AP exam when this question originally appeared. So is it reasonable to generalize the finding to all urban or rural 9th grade students in the US? And I hope you said no. If you left it at that, you probably won't get full credit. You need to explain yourself. No, it's not reasonable to generalize because we did not sample from all 9th graders in all rural and urban areas. You could probably get an E if you left it at that, but a stronger response would say, what can you infer to? We can only infer to the 9th graders at those specific schools. So that was D, a little bit of writing on that, but not too much. And then E, I've cut and pasted. This is the official scoring or the official solution from 2005, number 1C. But this says there's 2 plans. One plan is to have each student record the food consumed. Researchers would compute the caloric intake per kilogram. That's kind of what it sounded like earlier on. That's the plan that they used. And then plan 2 sounds a little new. Have each student record all the food they've consumed over the same 7-day period. So I record it for a 7-day period, you record it over the same 7-day period. Then researchers would compute an average. I hope that that one sounds really good to you. And then it's just explaining why that is. And again, I would recommend, I'm not even sure if they do this in the solution, but I would recommend if you have 2 options like this to even start your solution before you write anything. Maybe you have a pen and pencil there that you're writing. Just to remind yourself to do this, give a reason why plan 1 would be bad and why plan 2 would be, I won't say good, why plan 2 would be better. Now, it's not that plan 1 is wrong. It's more that plan 2 is better. So maybe I don't even want to say bad. Maybe I'll just say blah. No, shouldn't say blah. Okay, meh. So here's the official answer. Since we're assuming that students keep accurate records, plan 2 will do a better job. Okay, so clear. I know I encourage you to say roughly and approximate a lot. So sometimes students will say like, well, plan 1's good here and plan 2's good here. Like you just decide. If they're giving you 2 options, they want you to pick one. They're not wanting you to waffle like most stats teachers. And that sounds like a very good breakfast, waffle. Plan 2 will do a better job of comparing. Okay, that's just a lot of context. Both plans take the body weight into account, so that's important. That's kind of just side note. They're equal. If they didn't take the body weight into account, if one did and one didn't, then you definitely want the one that took body weight into account. But right here we get Plan 2 includes a 7-day period, and there are differences in caloric intake among the days. Ooh. That's really important, that there are differences among caloric intake. So when you're talking about Plan 1, it's only okay because maybe you give a concrete example. A student on one day may not eat much because it's Saturday and, oh, that's that, and they're at work and they don't get to eat much. Plan 2 is better because it takes into account that the food we eat varies day to day. Now that's not really a concrete example, but hopefully you get the point that Plan 2 is better because over a 7-day period, you're gonna have a much better idea of how many calories this person's eating compared to just one day. It would be better then to average over 7 days rather than considering only one day. So that's kind of that statement right there. That's kind of where they're doing the pro and con, that sentence right there. They're doing their pro and con. An average over 7 is stronger evidence, stronger knowledge about what the student's eating compared to just one day. So Plan 2 would provide a more precise estimate of the average daily intake. I kind of like that that statement there. It reminds me of something else that we could just quickly review and then move on. I need a little white space here. Remember, as we increase the sample size, the variability of our estimate decreases. So what would be better, sampling the caloric intake over 2 days or over 30 days? Well, over 2 days, you're going to have a lot of variability. Might even get a normal curve depending on the original distribution. But over 30 days, you're going to have way less variability in your statistic. And that's kind of related to the central limit theorem. Now, depending what we're doing with this, I don't know if we're really what these dots represent, if they're sample means or if these are just how many calories that you eat per day. But imagine if these dots were, let's say these dots, how many calories you eat every day, and you only sampled one day, and you say you randomly selected that day, you're going to overestimate where you typically fall. Whereas if you take all of these dots into consideration and find an average of those, sample mean, average of those, you're going to get a much better idea of how many calories that you eat. So I would guess on a question like this, you'd have to have very thorough answer, very specific, maybe concrete. Tell me why Plan 1's good, or sorry, bad. Tell me why Plan 2 is better, to be able to get full credit. So if you have 5 minutes left before the timer starts turning red, encouraging you to upload your response, if you have some time left, I would go back and see, hey, did they ask me to like justify my answer or to explain stuff? And can I elaborate a little bit more? You don't want to say too much, but giving a concrete example can be a really good thing and really help your score. Again, I appreciate you watching this video. If it was helpful, appreciate the thumbs up on the YouTube. Make me a YouTube star with 1 like. Let's do this.